Hey everyone, so I wanted to go through a homework problem from the homework from tonight actually. So I had to actually prepare for a little bit of a longer video because I think this one's going to take a bit longer than typical. So what I want to do is I want to go through question 3 from your homework actually. I did assign this question. Okay, so I'll basically be going through it with you. So either you can do question 3 first and then check your answer with the video, or if you have no idea where to start, you can take a look at the video and that'll help you with question 3 and then some other questions on it, okay? So question 3a says, what reference angle, which again, typically in class we call this the related acute angle. So what related acute angle on the unit circle should you use to find the trigonometric ratios for 225 degrees? Okay, so best place to start out with this would be to draw out a diagram of what this would look like. So we want to draw a diagram of a 225 degree angle on the unit circle. Okay, so here's my unit circle, right? Remember that it's just a circle centered at the origin on the Cartesian plane with a radius of 1, okay? And remember that we are going to have an arm going this way, which is called our initial arm, and then we're going to have our terminal arm, which is going to be where we're finishing our angle. We're measuring from the initial arm to the terminal arm. There's my terminal arm, and the angle between them is 225 degrees. And notice that we are measuring counterclockwise, as we should. Okay, so that's a 225 degree angle. And again, the question is asking us what is the related acute angle that we need to use to find the trig ratios for 225 degrees. So we need to find the related acute angle here. So I want you to remember that the related acute angle is going to be measured basically from the terminal arm to the closest part of the x-axis. And I want you to notice the closest part of the x-axis here is the negative x-axis. So we're going to be measuring from our terminal arm to the negative x-axis right there. Okay, so that's our related acute angle. We need to decide what angle that actually is. So some of you might actually be able to see that immediately because you see that it's a little bit past 180 degrees, right, to get 225. So essentially what we need to ask ourselves is, well, what do you need to add to 180 degrees to get to 225 degrees? An easy way to answer that is to do 225 degrees minus 180 degrees, and that gives us 45 degrees. So the related acute angle, or the reference angle, that we're going to be using to find the trig ratios for 225 degrees is a 45 degree angle. Okay, and we actually are going to be using that in question 3c, I think. So we'll get to that soon. 3b says, state two other angles that have the same reference angle, or related acute angle, on the unit circle. So we were dealing with a 225 degree angle in 3a. We want to find two other angles that are going to have a 45 degree related acute angle. Okay, so let me just draw out another diagram. Well, actually, before I get to the diagram, we know that our related acute angle is 45 degrees. Now for the diagram. Okay, so this is the diagram of the situation that we were presented with in 3a. We have our unit circle, we have a 225 degree angle, and of course it's got a 45 degree related acute angle. So where might we have two other angles that have the same related acute angle? Well, here's an example of one, right? So the one I've drawn in green here, notice that that has a related acute angle of 45 degrees as well, except for it's not in quadrant 3 like the 225 degree angle. This was in quadrant 2. So this is an example of an angle in quadrant 2 with a related acute angle of 45 degrees. Okay. Now the question is, what would that angle be? Well, we notice that it's 45 degrees less than a 180 degree angle, so 180 degrees minus 45 degrees is 135 degrees. So that is a 135 degree angle. Okay, the next one you're going to notice is in quadrant 4. Okay, so we have a angle in quadrant 4 with a related acute angle of 45 degrees as well. Okay, so we need to figure out what that angle is, and to do that, we notice it's 45 degrees less than 360 degrees. So 360 degrees minus 45 degrees is 315 degrees. So two other angles with the same related acute angle, but of course in different quadrants, are going to be 135 degrees and 315 degrees. Okay? 3c. So use a unit circle to find exact values for the trig ratios for 225 degrees. So we know that we're going to be using our related acute angle of 45 degrees in order to find the trig ratios of 225 degrees. Okay. Again, let's start by drawing out a diagram here. So here's our situation. We've got a unit circle, 225 degree angle, and a 45 degree related acute angle. Now remember that this alone is not enough to decide what the trig ratios are going to be for this, because we need another little rule, because The trig ratios for 225 degrees are going to be the same for the trig ratios as 45 degrees, but we need to decide when we have positive and negative values. So we need our cast rule. So CAST, the cast rule. So please remember that the cast rule stands for cosine, all, sine, and tangent. And what those mean are they're an indication of where the ratios are going to be positive. For example, if you have an angle in quadrant 4, you know cosine is going to be positive and everything else is going to be negative. If you have an angle in quadrant 2, then the sine will be positive and cosine and tangent will be negative. If you have an angle in quadrant 1, then everything's positive. Okay, so what the cast rule tells you is where the ratios are positive. So just keep that in mind. Okay. So what does this mean? So let's suppose we want to find the sine of 225 degrees. So the sine of 225 degrees. Well, that's going to be the same as the sine of 45 degrees, but we need to decide if it's going to be positive or negative. Well, 225 degrees is in quadrant 3, right? So we're talking in quadrant 3 here. And we know that according to our cast rule, tangent is positive in quadrant 3, which means that sine and cosine are negative. So the sine of 225 degrees is going to be the negative version of the sine of 45 degrees are related to acute angle. So we say negative sine of 45 degrees. Okay? Now, the sine of 45 degrees, we should know actually, that's one of our special angles. So the sine of 45 degrees is 1 over root 2. So the negative of that is going to be negative 1 over root 2. So in other words, the sine of 225 degrees is negative 1 over root 2. Okay, let's deal with the cosine. So the cosine of 225 degrees, well again, we're talking quadrant 3 here. We know that tangent is positive in quadrant 3, cosine is negative. So the cosine of 225 degrees is going to be the same as the cosine of 45 degrees, except for we need to consider the negative of that, the negative version. So cosine of 225 is equal to the the negative cosine of 45 degrees. And cosine of 45 degrees, well, again, we're dealing with one of our special angles here. Cosine of 45 degrees is also 1 over root 2, so we're going to have also negative 1 over root 2 rather. Okay, let's talk tangent. So tangent is positive in quadrant 3, so the tangent of 225 degrees will be the tangent of 45 degrees, right? Not the negative tangent of 45 degrees, the positive tangent of 45 degrees. And the reason why is we're dealing in quadrant 3, and tangent is positive in quadrant 3. Okay, well, tangent of 45 degrees, according to our rule, is 1. So the tangent of 225 degrees is also 1. Okay, so that's 3C. 3D. Okay, so 3D is state the exact values for the trig ratios for the angles in part B. So remember in part B, we came up with 2 other angles in different quadrants that had the exact same related acute angle as the 225 degree angle. Okay, I think it was 135 degrees and 315 degrees. And we have to come up with the trig ratios for those 2 angles. So we're going to split this page into 2. Okay, here's our first angle. Right, we have 135 degrees on the unit circle. It's got a related acute angle of 45 degrees, and we can clearly see that this is in quadrant 2. Okay, so in order to do this, I got to remember my cast rule. So I'm just going to write this in the bottom corner. Okay, now of course we're dealing in quadrant 2 here, which means that sine is positive, cosine and tangent will be negative, so we got to keep that in mind. And what that means is that the sine of 135 degrees is going to be, well, since sine is positive in this quadrant, it's going to be the same as the sine of the related acute angle, right? The positive version of the sine of related acute angle. So we get sine of 45 degrees. And the sine of 45 degrees is 1 over root 2. So the sine of 135 degrees is also 1 over root 2. For cosine, so the cosine of 135 degrees, well, since cosine is negative in quadrant 2, we know that it's going to be the negative of the cosine of 45 degrees. Cosine of 45 degrees is 1 over root 2, so we're going to have negative 1 over root 2. And lastly, tangent. We know tangent is going to be negative in this quadrant, since this is quadrant 2. All right, so the tangent of 135 degrees is going to be the negative of the tangent of 45 degrees, and tangent of 45 degrees is 1, so we're going to get negative 1. Okay, so that's for 135 degrees. Let's deal with the 315 degree angle. So here's a diagram. Unit circle, we got a 315 degree angle there with a 45 degree related acute angle. So we want to consider the sine, cosine, and tangent of this. Now, clearly we're dealing in quadrant 4 here. Our terminal arm is in quadrant 4. That is where cosine is positive, which means that sine and tangent are going to be negative here. So the sine of 315 degrees is going to be the negative of the sine of 45 degrees, our related acute angle. Sine of 45 is 1 over root 2, so we're going to have negative 1 over root 2. Okay, let's do cosine. Well, cosine's positive here, so the cosine of 315 degrees is going to be the positive version of the cosine of 45 degrees. Cosine of 45 degrees is 1 over root 2, so we get 1 over root 2. And lastly, tangent. Okay, so tangent of 315 degrees, well, tangent is negative here, so it's going to be the negative of the tangent of 45 degrees. And tangent of 45 degrees is 1, so we're going to get negative 1 again. Okay, so I hope this helps you go through the homework questions. This was just a kind of sample problem. I better not hear you guys ask me to do this question on the board tomorrow, considering you got a video for it. But if there's anything else from the homework you need me to go through, please feel free to ask. But yeah, I hope it helps, guys. Take care.